Students, welcome back. Now we will see another video for supervised learning. So today we will do some credit risk analysis. So let's read the context. That is, credit risk is nothing but the default in payment of any loan by the borrower. In banking sector, this is an important factor to be considered before approving the loan of an applicant. Dream Housing Finance Company deals in all home loans. They have presence across all urban, semi-urban and rural areas. Customer first apply for home loan. After that, company validates the customer eligibility for loan. Now the objective, that is, company wants to automate the loan eligibility process real time based on customer detail provided while filling online application form. These details are gender, material status, education, number of dependent, income, loan amount, credit history and other. To automate this process, they have given a problem to identify the customer segment. Those are eligible for loan amount, so that they can specifically target these customers. They have provided a partial data set. So basically what we want is, we want to find the customers those are eligible for loans, right, to avoid the credit risk or loan risk to unwanted customers. So we just want to automate this process. So these are all the variable in our data set. Now let's import the libraries. So first one is the matplot inline, so which will enable plotting graph in the Jupyter notebook itself. Now importing pandas, right, sklearn, again we will apply logistic regression here. Importing plotting libraries, right, so that is matplotlib. Importing seaborn for statistical plot, so seaborn as SNS. And from sklearn model selection, we are importing train test split, right, so importing numpy as np, then os and system. Now calculate accuracy matrix and confusion matrix. To do that, we will import matrix. So let's read the data frame, that is pd.read csv. I'll also provide the credit risk csv link in the description. df.head, if we run the head, so we will get top 5 attributes, I mean top 5 values. Now crdf equals to df.drop loan id and x is equals to 1. So dropping this column, as it will be 1-1 mapping always. So crdf.head, so it will return again all the 5 values, right? So crdf of loan amount term, now we are basically values count, so we are counting the values after normalizing it. So it will return all the values, right, that we have in the loan amount term. And sns.count plot, to plot this plot on the basis of loan amount term. So you can see that this is the loan amount term and the count. Now the loan amount term is highly skewed, so we will delete this column, right? So crdf.drop loan amount term x is 1 and in place to delete it permanently. Now again we are checking whether there are NA values or not. So we are summing all the NA value. Every column's missing value is replaced with 0 respectively. So crdf equal to crdf.drop NA, x is equals to 0. crdf of crdf.replace nan df.median. So if we check the crdf, here you can see all the values that we have. Let's analyze the distribution of the various attributes. So crdf.describe.transpose, right, so here you can see that we are transposing all the values that we have gotten from the describe function. Now we are checking that the count or the value count and plotting that on the bar plot. So here you can see that, right, this is a kind of bar. So for 0, this is the value count nearly 150, and for 1, there is the value nearly 350. So now for normalizing the value counts of loan status, for 1 you will get this value, for 0 you will get this value, right? And ax equal to sns.count plot, so x equals to loan status, u equals to credit history. So here you can see that the loan status and credit history respectively. plt dot figure or fixed size that we are getting is a 10 and 8, x equals to sns dot box plot, y equals to applicant income, x equals to loan status data, that is a cr dot df, right? So here you can see that this is the box plot that we will get from here. And similarly for co-applicant income, so here you can see that y equals to co-applicant income, x equals to loan status for this. So again the box plot for that. And similarly goes for loan amount. So y is loan amount, x is loan status. So here you can see that this is the loan status, this is the loan amount. Here you can also see the outliers that have been plotted. Now let us look at the target column, which is loan status, to understand how the data is distributed amongst the various values. So this is the loan status dot mean that we are getting. So here you can see that loan status, applicant income, co-applicant income, loan amount, and credit history. So here you can see that, right? This is what we will get. Convert x and y variable to a categorical variable as relevant. So CRDF equals to loan status, that we are getting values CRDF of loan status dot AS type category, and CRDF credit history equals to CRDF credit history dot as type category. So this is how you will get the convert x and y variable to a categorical variable as relevant. Now CRDF dot info, that you will get these values. So gender, married, dependent, education, self-employed, applicant income, co-applicant income, loan amount, credit history, property area, loan status, everything you will get. So there you will see that there is a slight imbalance in data, right? So how we can resolve that? So before doing that, let's do the model building. So we first define the x and y. In x we take all the variable except this loan status. In y we get the loan status variable. So this is how we identify the x and y, right? And convert categorical variable to dummy variable. So x equals to pd dot get dummy. So here is x, drop first we will get is true, x head. So this is how we will get the top 5 values of the x, right? Split into training and test set. So to get that train test split, again you will get the sklearn dot model selection. So you will get the train test split inside the model selection. So this is how you will get the x train x test, y train y test from train test split x y. Test size you will have the 30%, while training size you will have the 70%. Again random state is 42. So random state will do nothing but each and every time you will get the same data points, right? After this train test split. So from sklearn model import, now we'll be importing logistic regression, and then we are building the logistic regression model on the max iteration of 1000, right? So this is how all the values will be stored in logreg. Then logreg dot fit x train y train values dot rebel, you are passing this function, and this is how you will it will return the logistic regression. So civil, your one class is weight none, right? Dual false, fit intercept is true, intercept scaling is 1, L1 ratio is none, max iteration is 1000, multi-class is auto, and jobs you have none, penalty is 12, random state you have none, solver is equal to LBFGS, tool equals to you have 0.0001, verbose is 0, warm start you have is false. Now let's talk about the prediction. So predict for test state or predict for test set. So here you will get that log res dot predict x test. So it will be in your pred.text, right? In pred test you will get all these values. Now predict for train set. So pred.train equals to log res dot predict x train, right? And then from sklearn.matrix import accuracy score. So to get the test accuracy you will call the accuracy score passing the y test and prediction test, right? So then printing the test accuracy of NP round of test accuracy N2. So this is what you will get, the test accuracy. So remember that to get that test accuracy, you always call the accuracy score and pass the Y test and prediction test. Prediction test is nothing but your log-res prediction of X test. Again, log-res is nothing but your the logistic regression model, right? And you are passing predict of the X test that you have. So this is how the step will go look like. You will first define the logistic regression, then you will predict the X test in the logistic in that logistic regression, and finally you will get the predictor train, right? And then you will get the prediction for train set, and the test accuracy you will have the accuracy score of Y test and prediction test. And then to get the test accuracy, simply you will train the accuracy score, then Y train and prediction trains again, right? So this is test accuracy of Y test and prediction test, and this is test accuracy for Y train and prediction train. So this is how you will get your predictions. Now for confusion matrix, you will call the classification report and confusion matrix from SKLM matrix. Now matrix.train confusion matrix, we are passing Y train and prediction train, and confusion matrix train data you will get as matrix.train. So confusion matrix train data will be 5, 1, 6, 1, 5 and 40. So this is how you will get the confusion matrix train data. Similarly, to get that test data, confusion matrix test data, you will pass the Y test and prediction test. So this is how you will get the test data of the confusion matrix. Right. Finally, if you check for the ROC curve, so again to get that you will import ROC accuracy score and ROC curve, right, in the new variable that is logist ROC accuracy. So ROC accuracy score, from here you will pass a Y test log res dot prediction probability of X test, right, from these indexes, and FVR, TPR or threshold. If you get all these values, so again ROC curve inside you will pass Y test log res dot predict probability X test of all the columns. Now plot PLT figure, right, we are plotting that, and here you can see that we are passing the plot values all for the logistic regression and plotting with no skills, right? Then X limit, Y limit, X level, false positive rate, Y level, true positive rate, title. We are also providing legend for LOC lower right and save fig for LOG ROC. So here you can see that this is true positive rate, this is false positive rate, and this is the receiver operating characteristic. So here you can see how the distributed go like. Now the sensitivity is basically nothing but the true positive divided by true positive plus false negative. Specificity is nothing but true negative divided by false positive plus true negative. Sensitivity equals to true positive rate. Specificity, again from this formula you can see that the 1 minus false positive rate. Now G mean is nothing but the square root of sensitivity and specificity. So let's move forward to continue our AUC ROC curve. So again importing the same thing, but here you can see that now this time we are passing Y test log res of prediction probability of X test, and simply for Y test log res predict probability of X test. So calculate the G mean for each threshold. So here you can see that G mean is equal to square root of TPR. So the TPR is nothing but the value that we are getting from here, and into 1 minus FPR, right? Now Ix we are getting arc max of G means. So best threshold will return from here, right? Then we will plot that as a logistic regression, and these all are the plotting dimensions that we are passing the plot, and the scatter that we are passing black label is best, X limit, Y limit, X label, Y label, title, so on so forth, and finally we are saving the figure as log ROC. So here you can see that the receiver operating characteristic, true positive rate, false positive rate, and here you can see that the best that we got from here. So this is how our best has been plotted here, marked as O. And this is the logistic regression that is this area equal to 0.79, and this is our new skill. Okay, now if we talk about the precision recall curve, so here you can call the precision recall curve, right? Now y hat that we are passing is log res dot predict probability x test of this one. Now calculating ROC curve, right? All these values convert to F score. Okay, locate the index of the largest F score, and finally print best threshold, that is percentile F score percentile dot 3f. Now plotting the ROC curve for the model, and new skill length equal to this one. So this will all go like that. Now finally plt dot plot, so we are passing the recall, precision, marker and logistic, and plt dot scatter, we are getting recall ix, precision ix, marker o, color black and label best. Okay, axis label that we are passing recall and precision. So here you can see that this is how we will get this for logistic, right? This is our best here. Okay, and you can see that here is it is nothing but logistic. So yeah friend, this was all about the case study in the credit risk at any bank, right? Hope you enjoyed the video, and you also get several example for your case study and your problem as well. So yeah, stay tuned, we'll come up with some more videos. All the best.